Hi everyone, this is Shivam. Welcome back to the Kubernetes for Beginners series. Picture this. Your application is running fine, everything looks normal, and then sometime at night it crashes. No one is online, no one is monitoring the server, and there is no one to restart anything. But the users are still trying to access your application. This is one of the biggest fears in production system, and that is downtime. In this video, we will understand how Kubernetes handles this situation using something called deployments. So let's head to the presentation and we'll deep dive into it. So far in this series, we have learned an important thing. Application in Kubernetes runs inside pods. But pods are not permanent. They can crash, they can disappear, and they can restart at any time. If your application lives inside a pod, what happens when the pod dies? If nothing is watching it, your application is simply gone. This is where Kubernetes needs a manager, something that keeps an eye on your app all the time. And that something is called deployments. So what a deployment really does? A deployment doesn't run your application directly. Instead, it tells Kubernetes how your applications should look. For example, if I want this app to always have 3 running copies, then Kubernetes continuously checks the cluster and compares two things. What is running right now versus what should be running. If those two doesn't match, Kubernetes takes action automatically. Let's say you want 2 pods running all the time. Everything is fine. Now one pod crashes. At this point, Kubernetes does not panic because it is continuously watching the cluster. Here is what actually happens behind the scene. The kubelet running on the worker node notices that the container has stopped. It immediately reports the status to the API server. The API server updates the cluster state inside etcd, which is also known as the brain of the cluster. If you remember the second video of the series, where we discussed Kubernetes architecture, this is where those components come into play. Now the controller manager looks at this updated state and says, wait, I was told there should be 2 pods running, but only one exists. So it takes action. It requests creation of a new pod through the API server. The scheduler selects a suitable node if required, and the kubelet on that node creates the new pod. All this happens automatically. You don't need to restart anything. You didn't log into any server. The control plane noticed the problem and fixed it. This behavior is called self-healing. Now let's talk about scaling. Imagine your traffic increases suddenly, more users, more requests, and more load. With deployment, scaling is simple. You can manually increase the number of replicas, for example, from 2 pods to 6 pods. But in case of manual scaling, the load comes on the DevOps engineer, who has to continuously monitor the traffic and the physical resources of the cluster and need to take necessary action based on the load. But Kubernetes can also do this for you. Using autoscaling, Kubernetes can monitor things like CPU and memory usage. When load increases, it automatically creates more pods. When traffic goes down, it removes extra pods. So your application scales up when the demand increases and scales down when the demand reduces. You are not guessing traffic anymore. You are not scaling manually at midnight. Kubernetes adjusts automatically based on the real usage. That's what auto-scaling is all about. Now, here is an important mental model. You almost never work with pods directly. You work with deployments. Deployments manages pods. Services sends traffic to pods. So the flow is very clear. Deployment manages pods. Pods talk with services. And service talks to users. Once this clicks, Kubernetes stops feeling random. Now the question here is, why deployments matter in production environment? So without deployments, pod crashes and stays down. Scaling is manual and downtime is common. But with deployments, pods recover automatically, scaling is controlled, and application stays available. This is one of the main reasons companies trust Kubernetes in production. Now let's head on to the demo section and we'll see deployments in action. So this is my cluster where I have one control plane node and 2 worker node. Right now there are no pods running, nothing is deployed yet. Let's try to create a deployment here using imperative command. But before I apply this deploy command, let me run another command in this second git bash. This kubectl get pods command with -- watch option is used to monitor the status of all pods in real time. So we saw here in this terminal that there were no pods running. Now let's come back here and we'll apply this kubectl create deployment command and let's see what happens on this second tab. As we can see here on this first tab, it says deployment created. However, on the second tab, it says a pod named deploy demo was earlier pending. Then it says creating container and finally it started running here. Now remember one thing, I created a deployment, but not a pod. But on this tab, we can clearly see that a pod has been created for this deployment. Remember, in real Kubernetes, we almost never create pods directly. Now let's see our deployment. By the way, this deploy is a short form for deployment. You can either use kubectl get deployment or you can use kubectl get deployed. We can see here there is one deployment which is in ready state. This deployment describes how my application should look. So again, I created a deployment, but Kubernetes created the pod. And deployments don't run your application directly, but they create and manage pods. Now let me try to delete this pod. Here I'm trying to delete the pod manually. If this were Docker or a VM, the app would go down. So before I apply command, keep an eye on this other git bash tab. So let's apply this command. You see here, it says terminating. Then again, the same event happened and a new pod is now up and running. So if I do kubectl get pods here, you see, even though I deleted the pod, a new pod got created and it's the same one which is here. So I didn't create the pod. I didn't restart anything, but deployment noticed that the desired state was not met. And Kubernetes fixed it automatically. So this is how self-healing works in Kubernetes. And that is why deployment exists. In production, this happens even at 2 a.m. when no one is watching. Now let's look into the scaling part of deployment. So this kubectl get deploy demo deploy will fetch the specific deployment resource in my cluster. And then it will output the YAML format into this deploy.yaml. Now let's check what is inside deploy.yaml file. So this is our deployment file, and don't worry about these configuration if you don't understand. I will explain that in a later video, but for now just understand that the kind is deployment, the name of this deployment is demo deploy, and the container image is nginx. Notice something important here, the replica says 1. So this is the reason when we deleted the pod, it got automatically created. And this is the pod which got automatically created because we specified here that one replica of this application should be always up and running. And if we go down to this status tab, it says available replicas equal to 1. So this is where Kubernetes is checking the current state versus the desired state. Now I will increase the replicas to 3 by using this kubectl scale deploy command. And this -- replica specifies the number of replicas which has to be created. So let's hit enter and at the same time try watching this second git bash tab. You see here these events. Now it says 2 containers are pending, then 2 containers are getting created, and finally these 2 containers are up and running. Now if I do kubectl get pods here, we can see there are 3 pods. These 2 came up 20 seconds earlier, and this was the one which we created first. So this is how scaling works. Now imagine the traffic is low, so I'm gonna scale down the replicas. I'm using the same scale command, but here instead of 3 replicas, I'm reducing it to 1 replica. And monitor the second tab here. And if we see the events here, it says terminating, and that pod is now gone. So let's check how many pods are there. As we can see, we only have one pod left. Kubernetes removed the extra pod safely, no downtime, no manual cleanup. Now the full picture should be clear. Deployment manages pods, service sends traffic to pods, and users never talk to pods directly. This is why companies trust Kubernetes, because applications don't depend on human to stay alive. Kubernetes watches them all the time. Now we understood something very important. Deployments make sure your application stays alive, recovers automatically, scales when traffic changes. But there is still one big problem left. What about configurations? Things like database URLs, environment variables, API keys, passwords. Should we put all of that inside our Docker image? What happens if we want to change our configuration without rebuilding the image? That's where config map and secrets comes in. In the next video, we will understand why hard coding configuration breaks your Kubernetes app and how Kubernetes handles configs the right way. So that's it for this video. I'll see you in the next one. Till then, keep learning.